All right, so we've seen how we can find the coordinates of a point on a unit circle, but what if we have a bigger circle? What if it's a circle of radius r? Can we find the coordinates of on a circle of any radius? All right, so here in this diagram we have a unit circle. The small circle is the unit circle with a radius of 1, right? Now if we draw another circle centered at the origin but with a radius of r, right, you can see that we get these two triangles. We have this triangle here, which was our this triangle here, which was the one on our unit circle, right? So there's one triangle. Now we also have another triangle here, right? We have another triangle here, and these two triangles are similar, right? We can see that all of the angles have to be the same because two of them are the same, right? We have um, they share the angle theta, and they both have a right angle, so that means the third angle also has to be the same. So anytime an angle or all the angles of a triangle are the same, then those triangles are similar and their side ratios, they have the same ratios as their sides. And so, but basically what we have here is just a scale model, right? We're just scaling up the little yellow triangle by a factor of r, right? Because we're taking this side length of 1 and scaling it up to a side length of r, okay? So we're scaling up that yellow triangle and turning it into the pig triangle. So all we have to do to find the side lengths of the bigger triangle, the one with a hypotenuse of r, is just take the side lengths of the smaller triangle and multiply everything times r. Right? We're just scaling up by a factor of r. Okay, so the coordinates on a circle of radius r are going to be the x-coordinate is going to be r times the cosine of theta, right? Because the cosine of theta is the x-coordinate on the unit circle, and then we're just scaling that side length up by a factor of r. And the y-coordinate on a circle of radius r is r times sine of theta, right? So we're just taking the vertical leg of the triangle and scaling it up by a factor of r. So, all right, let's do one more example here using this this concept. So this is it says find the coordinates of the point on the circle with radius of 8 corresponding to an angle of 150 degrees. Okay, so given that if we're just going to take the radius is 8, and we're going to multiply it times cosine of theta to get the x-coordinate. And the y-coordinate is going to be 8 times the sine of theta. So now we can figure this out if we can figure out the sine and the cosine of 150 degrees. So maybe I should actually replace the theta with 150 degrees. That would make sense. All right, so let's do that. Let's replace the theta with 150 degrees, right? Because our angle is 150 degrees, our radius is 8. All right, so let's figure out the sine and cosine of 150 degrees. Now, what I like to do is just draw a unit circle. So I have to kind of visualize what's going on here. Where is that angle? Now, 150 degrees, right? This is 180 degrees. So I'm not quite there. I'm 30 degrees shy of 180. So this is 150 degrees here. And the reference angle is 30 degrees. Should make this bigger. The reference angle is 30 degrees. Okay, I'm going to draw my little triangle. So what I have is a 30, 60, 90 triangle. I should make that bigger. I wonder if I can just lasso it and make it bigger so that you can see what's going on. Let's just try that. Let's make it a little bigger. Okay, it's a little lopsided now, but that's okay. All right, let's make it a little bigger. All right, so let's fix that 30 degrees here. Let's make it a little more clear. So the reference angle is 30 degrees. I have a 30, 60, 90 triangle, and I've memorized the sides. If the hypotenuse is 1, then the short side is a half, and the long side is square root 3 over 2. All right, so that's telling me that the cosine, oops, but that's a negative square root 3 over 2, right? So X is equal to 8 times the cosine of 150 degrees. And the cosine is this horizontal leg. And so we're going to multiply that times a negative square root 3 over 2. And then we're going to simplify that down. Right? 8 is the same as 8 over 1. Multiply the fractions. Now I can cross cancel this and make it a 4. And and then I'm going to get a negative 4 times the square root of 3. All right, so that's my x coordinate, x. All right, now the y coordinate. Let's do the y coordinate. So the radius is 8, and the sine of 150 degrees is a positive 1/2. So just take 8 times a half, and we're going to get y is equal to 4. All right, so my final answer, let's go ahead and write it as a coordinate pair. So x comma y as a coordinate pair is going to be the negative 4 square root 3, negative 4 times the square root of 3, and the y coordinate is 4. All righty, well, that's all I have for you today, and I'll see you in class.